Hello YouTube. I want to show today the steps I did in order to connect beaglebone, I2C and SPI through device overlay. Everything is done using the buildroot image. Um, the idea is that most of the device tree tutorial and examples in the internet are referring to the cape manager, but the build doesn't have cape manager. So how do we take overlays and use them in order to configure pinhooks, in order to configure ports? So finally I found the solution, and then I did I2C using the beaglebone and using also the Raspberry Pi. I will show both, and I connect them to a Kinetis KW40Z. And the next video I will continue showing how do I configure the KW40Z and build the echo program between the beaglebone and Raspberry, and vice versa. As the beaglebone is the master and the KW40Z is the slave. This is a microcontroller. It has also SPI, I2C. It's a small microcontroller for Bluetooth. So the first thing we need to do is to make an image, and in order to make an image is beaglebone in buildroot is quite easy. So the only thing we need to do is to download buildroot, and from the configs choose the beaglebone def config, and just do make. And after we did it, we can wait several hours, and we will have the image ready in the output images. So we are focusing today on the device tree of the beaglebone. Why? Because we want to add I2C devices. So we can find in many places the pin routing of the beaglebone. For example, this is for the two I2C ports. We can see that I2C1 is SCL pin 17, I2C1 pin 18 is the SDA. We also have it in pin 24 and 26. So how do we take an overlay and configure the pin, because we don't have the cape manager? So I wrote a document here, and I want to show you what I did. So basically, the overlay itself contains two fragments for the pinhooks, for example. The first fragment is target for the AM32X pinhooks, and the second fragment is targeting for the node itself. So if you go to the DTSI, the bone common DTSI, we will see here, this is the pinhooks area, and we have a pinhooks for user LED and I2C0, and also we have for the default I2C2. I added here I2C1. So the question is from where I took it. We can find it in the internet, anywhere that we have the I2C, all the overlays for the pinhooks. I have it some here in the document. I don't go to follow it, but actually, so we have this. This is the address. This is the offset from the register, and this is the mode. We have mode 2, pull up, and slow sketch. So this configured the I2C1, and this is configured the I2C2. We can see here that I added also SPI1. We need to make sure that SPI 0 and SPI 1 using the same pin, so we can choose only one of them. So I choose SPI 1, and again I took it from the overlay code itself. So then I need to change the bone black itself. I need to add a node. So this is I2C2 node. Is using the pin control I2C2 pins. This is the clock frequency, and this is the I2C1, and this is the SPI1. SPI1 is using SPI dev 1 max frequencies, and is using the SPI pin S0 that we have in the common DT side. So again, what we are seeing here, we are changing the device tree overlay manually because we don't have the cape manager. We are taking the overlay from the internet. Okay, what else we have? I found a very cool site for the beaglebone. It's called beaglebone device tree overlay generator. Very nice website that you can select the pin itself, the mode. Let's go to this website. Very good. So for example, we can go to P9. This is the header of the P917. We can see that is I2C1 SEL. We can make it input, pull up, and slow, and we have the fragment here. So what they did is just took this code to the common DTSI and took this code to the beaglebone. We have it ready already. Don't have it here, but you can find everything in the internet. Okay, so after we did the changes, we don't need to recompile the code. The only thing we need to do is just delete output. We need to delete the stamp, the output build Linux stamp build, stamp configure, and also what I did. Output Linux ouch .dtb. Don't delete the DTS, of course, the DTB, and also delete it from the output image am bone black.dtb. Once you do it and you press make, it will build the it will compile the changes of the DTS. What is also nice to do, if you want to make sure, you can go to the beaglebone DTS, change the model here to add your own naming. For example, TI buildroot 3.0. And why? Because we can then go, after we load it, we can go to do cat rock device tree model, and we can see that this is the actual device tree that was using in the boot, using the U-boot. So because Okay, regarding the SPI, so there we can see that we have three I2C character devices, I2C 0, 1, and 2. And they will appear only if we add the right pinboxing. Regarding SPI, after we added the SPI, the reason we have it here because we did mode probe SPI dev, and this loaded the SPI dev device driver. And what is important also that in the kernel using Linux dash menu config, we need to make sure that the user mode SPI device driver support is specified as a module here. And after we did this one, configure the SPI pin and did the mode probe, we will have the SPI driver shown in /dev. Okay, so and in here, this is document. It will be in the description below and also in my GitHub. And you can have okay, you can see the flow. I just documented everything I did, and this is taken from the TI website, explaining what exactly the PMUX and how it configured. Okay, that's it. So the main idea here is how to configure using using buildroot the overlay that we don't have the cape manager. So we manually edit the files, taking the content of the fragments and insert them into the beaglebone DTS, the device tree overlay, device tree. Once we do it, we don't need to recompile and make clean everything. We just delete the stamp file, DTB, and did make. It will take like 1 minute, even less, and it will compile the image again. You can take the new SD card image, burn it, and follow the steps here. And so you can search the my GitHub here, and I have it in my documents. I have everything. It's almost everything about buildroot, so you can find it here, BBB, and you have this document, beaglebone device tree changes instead of overlays. This is the document. So thank you very much. And the next video, okay, let me show you one thing. Ask I to okay. So I forget it. I just connect the pin to I2C2 and not I2C1, and we can see here that the KW40Z is responding with the slave ID. So the next video, I will go through the KW40Z setup, and the code itself, everything is on the internet, on my GitHub. So hopefully that you enjoyed this video, because It's not so easy to prepare video. It took me like more than 1 week to learn everything. So I want to share with you and enjoy. Thank you very much. Bye bye.